All right, so I thought I'd show you how the stair examples play out from the example in the lecture. So this is the 8 feet 2 1/4 from the slab rather to the finished floor of your first floor, and we came up with in our calculations for the example for the basement, we came up with a total run of 10 feet and 13 risers and 12 treads, and the riser height is 7.56 inches or 7 and 9/16, and the tread depth is 10 inches. So those are the numbers that I need to use to actually build the stairs. So I'm just going to assume that the stairs are going up in this direction. So I'll just kind of randomly start a line as a construction line somewhere around here. And I'm going to use the divide tool to divide this into 13 segments. And then we'll use P-type to change the point type so I can see them. And I'm going to draw a line. Let's see, actually, let's offset this line 10 feet, because that's going to be the run of the stairs. And then we'll just draw lines between the nodes and copy them. So I'm just going to turn on node as a object snap and copy that down. So essentially, by me using the divide tool, I came up with the same riser height. And if I have 13 risers, let's find that out by putting in a dimension from node to slab, and I got 7 and 9/16. So it just equally divided that, and we came up with that number. All right, so now I want to put in the tread depth. So I'm going to offset 10 inches for each tread. And we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 treads. So the stringer starts here. So let's make those treads make sense by filleting them together. You can actually see the stairs taking shape here. And through the math that we used, that looks like that's going to work. So this is going to be our first step up. Now I'm going to off to the side create a rectangle that's going to represent the tread. So I'm going to go at 11 1/4, comma 0.75 inches. So we're using a 1 by 12 for a tread in the basement. I'm going to move that 1 by 12 so it's sitting on top of that first riser. And then I'm just going to copy that up and put that in the same spot in the last riser here, and I want to show you what happened. The distance from, let's put in a linear dimension. The distance from the finished floor to this first riser is now 6 and 9/16. The distance from the first riser to the floor is now 8 and 5/16. So the reason that happened is because we put the tread on top of the stringer dimension, and it added 3/4 of an inch here at the top, and it subtracted. I'm sorry, it added 3/4 of an inch to the height here at the bottom and subtracted 3/4 of an inch from the top. So what we have to do is take this whole thing and move it down 0.75 inches, or that dimension that's equal to the riser. And now we should have the correct riser height here and here once we fix that dimension. So we got 7 and 9/16 here, and we got 7 5/16 here. I suspect, oh, look at that. I made a mistake. And so the position of all these nodes isn't quite right. So let's do it again. Let's walk through that whole process again. But just wanted to show you what is meant by dropping the stringer. And dropping the stringer has to do with making sure that the dimension of each one of the risers is not any variation more than 3/8 of an inch from any other riser. So let's use that divide tool one more time. Select, and we want 13. Now offset 10 feet. Okay, we should still get about the same dimension. Let's find out, because I don't think we were off by much. Yeah, but it was off enough to make that last tread, riser height rather, off by a little bit. So offset 10 inches. And then we'll fill it from the top tread down, just like we did before. Now everything's correct. So let's see, let's do that tread depth thing again and see if we get the same number when we drop the stringer, if you will. And this time around, I'm going to make it a little bit clearer by, let's get rid of these nodes now, by actually making a stringer. That will make more sense. So from this first line here at the top that's representing the top edge of the finished floor that we're going to, down to the last point that we have here, you can see that diagonal hits the points of all of those risers. I want to take that line and copy it, actually offset it 11 1/4, which would be equivalent to the width of a 2x12, and that will make up the stringer. So I'm going to delete that top line and then fillet these corners together. You can see the stringer taking shape here. So we would take a 2x12 and we would cut out in the stringer these little triangle pieces to make up the rise and the run scenario. And then the last piece here, we would just fillet. And this here is our actual stringer. So I'm going to switch to a different line weight and show that there would actually be an opening in the floor here where the stringer is hanging on the floor. And we would have two headers side by side that are making up the opening for the floor. And we'd also have the same two headers on the other side, more or less aligned with the last, the nosing of the last riser. So that's the stringer right there, this whole piece. Down here you'd have what's called a toe kick that would be nailed or secured into the concrete slab in this case. And then this is pinning the stringer so it's notched. So this would be bolted to the concrete floor, and then the stringer would be notched here so it wedged into that, keep that from wanting to kick out, and then it would be hung up here. Okay, so actually let's make this right. These line weights are important to get right. So this would be a thicker line because it would be in section. And then this would be a thicker line because it's in section. And then we'd have a thin line here. There we go, because that's beyond. And then between here and here, you'd have a bit of, let's go out 0.25 inches. Actually, not 0.25. Let's go out 1.25 inches. And draw some gypsum wallboard here. This will be the finish that we'd see on the inside face of the opening. And I'd basically trim between these two lines here. Do it this way. And then I just see a finished edge here. And usually, like with a basement, you have walls that are enclosing the space, but this would be the opening here for the stairs, and this would be the floor system that we're seeing beyond. So that opening, I'm just trying to represent with thinner lines. So if I show the actual line weights, you can see that being represented here. So let me tone down that line difference. There we go. So to finish building this whole stringer, let's put that tread on top of there again. And now this is going to make a whole lot more sense. If we create our tread at 11 1/4 by 0.75 inches, going on here. Oh, I'm sorry. 11 1/4, comma, 0.75. And I need to put the @ symbol in front of there. I've been using a lot of Revit lately, and I was putting in numbers that would work with Revit. Okay, so there's our tread. If we move our tread to the correct position, resting on top of that first stringer, and copy that up. Whoops. To the last tread at the top. Now we'll put in our dimension. That's 7 13/16, and then this is 8 5/16. So that wouldn't fly. That would not meet code. So we have to take and move the entire stringer down equal to the tread depth, 0.75. And if we do that and adjust these dimensions to the new location by us moving that, then now we're back at 7 9/16. And up here, we're back at 7 9/16. So now everything is evened up again. And if I take that same tread and I move it to the top of every tread point like this, no matter where I place the dimensions, I should get the same number. Let's see, just kind of randomly do it. 7 9/16. So I've now designed a set of stairs that have the correct riser height, and none of the risers are varying any more than 3/8 of an inch. In fact, they're not varying at all. And my tread depth is stayed the same as well. So if I use the dim linear command to measure the tread depth, no matter where I measure it, even here, it's going to be the same dimension. This also illustrates why we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 risers. The last riser is the step up onto the next level. And we only have 12 treads because this is not counted as a tread. So the treads just happen on our stringer, and that's it. So we're always going to have one less tread than a riser. So let's check to see if we've got our head height set appropriately. So this is how you would do that. You would draw a line from nosing to nosing, and then copy, not offset, but copy that line up the 6 feet 8 inches that's required. And then this tells us exactly where that opening needs to be. So we actually have to move this back a little bit further. So let's stretch that opening far enough over so that it clears, and then we're all set. Line here so that we can just get that to extend without the angle changing. There we go. So now you've shown that the headroom is going to be maintained, and we can even put 1/2 inch gypsum wall board here to finish that corner. If we wanted to finish the basement ceiling without strapping, we could do it that way, and still have that headroom. So that's how you measure the headroom. And this headroom determines how wide this opening has to be for the stairs. So if I had a lot longer set of stairs, I would only need to provide the headroom space over that first 12 treads. So if I had like 16 to 18 stairs here, treads, I only need to expose or provide the opening over the last 12. And I know then that I still will have my headroom. That's basically what you can take away from this. So the second floor, if we're going to do the same thing, and I'm actually going to mirror these stairs because I wanted to go up in the other direction. So I'm going to mirror these stairs like this. I need to make sure this landing space from the foundation wall to where we get off the steps is at least 3 feet. It's 3'9", so I've got plenty of room. And on the first floor, I might want to go up the stairs coming through the front door. The stairs often are located right in front of you in a lot of traditional homes. So the stairs are usually stacked on top of each other because then they all automatically create natural head height in the space. So let's get rid of that. Well, actually, let's mirror that also. There. So if we build the stairs here, I'm going to make sure I have my lines set up correctly this time. We go back to the stair lesson. The second floor stairs, we require 15 risers with a riser height of 7 7/16. And then we need 140 inches or 11 feet 8 inches of run space because we've got 14 treads times 10 inches. So I'm going to take this line and offset 140. And then I'm going to use the divide tool again and divide that into 15 risers. And we'll draw lines across. And then offset 10 inches again. You could use array too. I'm just being lazy, I guess. Lazy people work harder. All right. And from here, I want to start creating those steps. So I'm just filling the grid. Let's see if it all works out. All right, so there's where my stringer is. And if we fill out the other side, so you'll see that the stairs are not coming out exactly the same because we had different riser, total rise heights. I had a total rise of 9 feet 4 inches on the first floor to second floor. So these stairs that are being designed for this level are a different rise and run ratio than the ones to the basement. So to create that stringer, go from nosing to nosing, offset 11 1/4, and then close the stringer. So this is going to be where the stringer is going to hang onto the floor. So I'm just going to copy this up. And that would look something like that. And you get the idea for, you know, how this would look over here. And we do the same kind of trimming and making sure we had our line weight showing up correctly. So let's double check these dimensions and see if they came out right. We'll do a dimension here. From here to here is 7 7/16. Same concept though, I've got to drop the stringer. So I'm going to move the stringer the same height as my thread that I'm going to use, and I'll use 11 1/4 again. So 0.75 inches. And if we use the same threads here, we should end up with the correct dimensions on each riser, just like we did down in the basement. Fix the dimension down here, 7 7/16. Do another dimension up here, see if it comes out to be the same. That's going to go to the top of the finished floor like that. And just check somewhere in the middle, but we know it's right because we did it with AutoCAD. The AutoCAD did our math for us. And then check any one of the tread depths. Now notice I'm going from nosing to nosing. You can also do from riser to riser. That would work too. You should get the same number, but you don't want to go from riser to end of nosing because that's going to give you a different number. That's the length of the actual tread we're using. And that's the surface area for your foot, but the actual tread depth is counted from the same position in both directions, nosing to nosing or riser to riser. So there are stairs for our second floor. And let's test the theory because this is 15 risers. I'm going to draw a line from nosing to nosing all the way up. And this I'm going to copy, not offset, that up 6 feet 8 inches. And this shows us where we have to put our opening for our stairs. Somewhere around there. I mean, given the fact you're going to have some finishes and stuff. And then let's look to see where that happens over that second riser, tread rather. So see how the opening, still we just need to have exposed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 treads, even though we have 15 risers and 14 treads, those 2 at the bottom, it's okay for us to have floor framing over that because we're going to still have our head height. So that's an important thing to understand with stairs and runs, how much of that floor area needs to be open for those stairs. Typically ends up being about the same. And so up here we could have a closet on that second floor in one of the bedrooms. So we might come up in the center of the room like a cape. If you think about a cape or a colonial, the stairs are centrally located. And then you go to a bedroom on either side maybe, and the bedroom, one of them anyway, could have a closet, or you could split that closet in half if these stairs are wide enough. Let's say the stairs are 4 feet 6 inches, then each closet could be about 2 feet deep. And you could have half, closet in one room and closet in the other. So how does this look in plan? Once you have generated the correct dimensions for your section, you can go back and you can put that information in your plan by projecting it. So if I were to draw using the wall tool here and draw my exterior walls up here, let's just get We don't actually need that. We'll draw another line for the inside of the wall. Oops. That in 0.5 inches. Okay, so that's it representing the exterior wall. If I wanted to see what are my stairs going to look like, I might use the stairs layer and draw in the lines for the treads. So just going to copy that line over to each tread. And we'll pretend that this is where the center door is. So we'll put a door, oops, right here that's going into the house. So centered on that door, we're going to have the width of the stairs. And this is representing the inside width. So our stairs would be between these two lines here. And then we would put in a break line whoa, break line got really long, didn't it? So we put in a break line, and then this half of the stairs we'd project from the basement. So I'd trim that half. And let's see if we can just move these over by referencing where we are here. First tread should be here. Now we've got the stairs that are going up to the second floor being represented on one side of the break line, and the stairs that are going down to the basement. And if I keep using an offset of 10 inches, that should be correct because that's my tread depth. So there's what our stairs would look like in plan. And then you'd probably have wall around that. So we offset the wall 4.5 for the wall thickness on the inside. And maybe on this side, it's just open to go up to the second floor. But on the other side, we would have most likely a door going into the basement that you could open and close and keep the basement closed if you wanted to. So that's what we would see in plan. The plan is generated from our dimensions that we have with so here's where our wall would be, right here. And it would just kind of fall underneath the stringers. That's okay that's running into it would just like help hold up the stringers. And let's see, did this wall end up being in the right place? Let's find out. Oh, okay, I didn't quite get that in the right place. There we go, now it's in the right place. So that's how you would figure out where your dimensions would be, and then plan view, you'd check them with your section. So when you're designing a set of stairs to begin with, you can come up with approximates and say, all right, I know that I'm going to be doing a straight set of stairs, so I'm going to need 13 feet by 3 feet of space. That includes your landing. So if we put the 3-foot landing in here, there's the landing, and then there's the opening for the set of stairs that you'd need for clear space on that level. On the second floor, you'd have the same thing. You'd need a landing, but on the opposite side, plus the 12 inches. So this is a good way to start, just to kind of ballpark where something's going to be. But then once you've actually done a stair section, that's what's really going to inform you of where those walls are going to be on that plan view. And whenever you're designing stairs, regardless of if they're L-shaped, U-shaped, whatever, those stairs are going to be designed first as straight stairs based off of the same dimensions that we used. And then what you can do is take one of those. Let's say we wanted to make a landing here. I would increase the width of that so that it was 3 feet wide, and then the stairs from then on would end up being, I would see them beyond. So this is how I would generate an L-shaped set of stairs. So see how the dimensions and where your landings aren't going to change. It's just that the stringer configuration, oops, not sure what happened there. So the stringer configuration changes because we're changing direction, and all of these would just match. Get rid of that. So from here up, we'd see the stairs facing us or from behind until we got up to that level. So now our stairs, this is an example of an L-shaped set of stairs. So there would be a landing here, go up the stairs, hit the landing, change direction, and continue up the stairs that way. So you see that the dimensions that you come up with for that straight set of stairs are the critical ones, and then we just reconfigure them. If this was a U-shaped set of stairs, whoops, try that again. I want to make sure I have enough room between the two. Then the stairs would continue up in this direction once it hit the landing, and that's a U-shaped set of stairs. So you go up the stairs, hit the landing, and then go up the stairs that way. So again, once you've figured out everything, then you've figured out all the critical dimensions, and you can just manipulate that and change where everything lands to make them into a L-shape, U-shape, whatever type of set of stairs. So this is the most important thing for you to understand how to do, is take those calculations and translate them into a stair section that actually works.